Hello, welcome back to the channel. Okay, I hope you like the content thus far, and then you can subscribe and like the videos. For now, what we are going to be doing is drawing or sketching hyperbolic functions. But we're basically just going to be looking at one example because there isn't much about it. So remember, the equation is f of x equals to a over x plus or minus p plus or minus q, whichever one they put. So I'm just going to put it like that for now because they can use a plus or a minus, and it really doesn't make that much of a problem, because the plus for a p means to the right, to the left rather. Plus p means to the left, and then minus p means to the right, and then plus q means upwards, and then minus q means downwards. So just to kind of maybe make a demonstration of what I mean by upwards, downwards, basically the original function was something like f of x equals to a over x. It was just that. And when it was just that, when a was positive, the graph was here in these two quadrants like that. That's for a being positive, mean greater than 0. And when a was negative, the graph was just something of this nature. I keep saying was. It could be an is. So in a present tense, when a is less than 0, it could be something of this nature. And then the asymptotes in this case, whether a is positive or negative, when q and p are 0, the asymptotes are actually coinciding with the x-axis and the y-axis. Okay. However, now when we start having a situation where q is no longer 0 and p is no longer 0, the asymptotes are being moved, and as they move with their functions. So when the function moves upwards as a whole, you can have a situation like this. Okay, let me use the same colors to avoid confusion. The x-axis and the y-axis will remain where they were. Okay, so when we say plus q, that horizontal asymptote is now somewhere here at that value of q. Okay, that, let me just put the value of q becomes here, because when you have what is it, f of x equals to a over x plus q, that's the situation that you're going to have. And then if a is still positive and you only had plus q, but p is still 0, that means for p, the vertical asymptote is still where it is. It hasn't moved. Okay, and then what that means is a is positive means the graph is still like this. Okay, you see what happened by just adding q. If q was maybe subtracted, or you had minus q, okay, let me leave this one and then have another one here, a over x minus q. That would basically mean instead of the asymptote moving from the horizontal asymptote moving from the x-axis going upwards, is now coming downwards here in pink, and the graph was basically going to look like this. Let me use which color? I'm going to use black to represent the graph, because for this equation the graph is going to look like this. Okay, as well as this. I hope you see the difference. Okay, so that's basically how it was going to look. So the moment they start adding or subtracting p, it's just a matter of moving the vertical asymptote either to the left or to the right. When you add p, say plus p, you're moving this to the left. When you say minus p, you're moving the asymptote to the right, somewhere there. And then the graph moves with the asymptotes. That's basically what's happening. But the x-axis and the y-axis, they remain where they are. Okay, I hope that can maybe create some clarity. If it doesn't, the video was about sketching, so let's sketch for now. And then I will try to clarify it for those who say it doesn't really make that much sense what you just said. Okay, suppose you're given this function and you're required to sketch the what you call the hyperbolic graph. Okay, so one thing you can look at is the fact that you have a plus q, and then you have minus p, and then you have a positive a, right? This is plus q, this is minus p. So basically, this is the function in the format y equals to a over x minus p plus q. That's what I'm saying. And that means your p is equals to 1 and the q is equals to 2, while a is equals to 4. That's what I'm saying. So to sketch this, you first need to identify your what you call asymptotes, because you're gonna need those asymptotes. These are lines that the graph continuously approach but never touch. Asymptotes, you have the vertical one, the vertical asymptote, which is this one of p, that is x equals to p, that p is already 1. And then the horizontal asymptote, it's y equals to q, which is 2 in this case. Sorry. So now we are done with the asymptotes. What else do we need? We need the intercepts, if they will exist. Let's try with the x-intercept. We let y equals to 0 to get the x-intercept, but we have the function already given to us. So when you let y equals to 0, that means 0 is going to be equals to 4 over x minus 1 plus 2. We just move the 2 to the left. With minus 2 equals to 4 over x minus 1. Cross multiply, we can have minus 2 into x minus 1 equals to 4. That means we have minus 2x plus 2 minus 4 equals to 0. Okay, why did I move the minus 4 to the other side? That was such a wrong move, an unnecessary move. So let me leave it there. So minus 2x equals to 4 minus 2, that is 2. Then x is equals to negative 1. That is your x-intercept, or the x-intercept is minus 1 and 0. And then the other thing we can do for ourselves is to find the y-intercept. Okay. So when we get the y-intercept, we let x equals to 0. So by that we mean y is going to be equals to 4 over x, which is 0 now, minus 1. What was there? Q, it was plus 2. Okay, I hope now you can still see. So that therefore means y is equals to 4 divided by y, but you have a negative 1, basically minus 4 plus 2. So minus 2, that is the y-intercept. So the y-intercept is 0 and minus 2. So I hope now we have all the information that we need to sketch. Okay, yeah, that's basically the information that we need to sketch the graph. And sometimes they also, it's all the information, but sometimes they might also require you to, okay, to include the axis of symmetry. So for the axis of symmetry, I'm just gonna add that here. For the axis of symmetry, we can have the positive axis of symmetry, or the increasing one, if I can just put them like that. Sometimes they can call them an increasing one. That is the one with y equals to x plus k. And then decreasing one, I'm gonna do it there. Decreasing axis of symmetry is y equals to minus x plus k. So for each of these, to get the value of k, you just need to substitute your intersection point of the asymptotes, and that point is substitute the point that is p and q. In our case, the p it's 1 and the q is 2. 1 and 2 into this equation, and then solve for k. So when you substitute that, we have 2 equals to 1 plus k, therefore k is equals to 1. And when we substitute in this decreasing function, we have 2 equals to minus 1 plus k, therefore k is equals to 3. Therefore, the functions now, it's for the increasing one, it's going to be y equals to x plus 1. For the decreasing one, is y equals to minus x plus 3. So you have the two equations for the axis of symmetries. Okay, now we can even include them in our sketch. So I'm just going to do the sketch here on the side. Okay, so here we are. That is the Cartesian plane, the axis, and the y-axis. From there, what do? We include the, okay, I'm just going to use different colors to include the asymptotes. X equals to 1, that is the vertical asymptote here. And then just do that. Okay, if you hear some noise in the background, guys, just know I don't own the title deed of YSD. So it makes sense. Okay, and then if for the horizontal asymptote, that is okay, let me even give the equation the name or the formula. For the horizontal asymptote, it's y equals to 2, that is q. Okay, that's going to be this one. See how easy it is, guys. This is why you have the 2. So the function, you can even give it its equation y equals to 2. Now you have the 2, and then you know for sure what to know. The value of a is positive. So if a is positive, what do? You're going to plot in the first and the first and the third quadrant. The first and the third quadrant. That's where you're going to have your graph. This one, as well as this side. Okay. Then you can indicate your intercepts. The other one is negative 2, that is the y-intercept. The other one is negative 1, that is your x-intercept. You are pretty much there at the end. However, you still have your axis of symmetries. Axis of symmetries, let's start with this one, the increasing one. Increasing basically just means the y values of that function, they are increasing when the x values are also increasing. Basically, when you move from left to right, the y values of that function, they are going up. As you can see, this is the case with this one that I just drew now. The equation you use, I think the axis of symmetry also always use the broken lines. So y is going to be equals to minus x plus 1. And then the other one, it's this one. Okay. So wait a moment. I'm busy sketching this, but not taking into account the fact that it has the increasing one, it has the y-intercept of 1. So it must pass at 1, not where I'm taking it. It's not at the center. So it must pass at 1. Its y-intercept is 1. So make sure you don't do that error like I just did now. Don't make the same error that I just made, basically. Okay, so this is where the 1 is. So yeah, that's basically what you need to do. And then the other one, which is the decreasing one, its y-intercept is at 3. So you make sure that it passes through the intersection point of the asymptotes, and it also passes through that positive 3. That is your axis of symmetry. And then you are done sketching this thing. That equation for that is y equals to minus x plus 3. I think you've given everything, but the main equation you haven't provided in it, so you must provide that one as well. F of x equals to 4 over x minus 1 plus, was it plus 4 or what? What is the equation? Oh, plus 2. Okay, then you're done. I think we have covered everything. That's basically how you sketch this thing. See you in the next video. Like, comment, share, subscribe, and do all those good stuff, and then I see you in future.